Alrighty, so you've been looking around, you've seen a couple of the network layouts, and you figure out which one's going to best work for you. Now let's take a look at cables, the type of cables that you're going to use to connect this network. Right now we're going to take a look at the RJ11, RJ14, and RJ25, which look like this. This particular plug has 4 pins. This next one over here has 6 pins. So the RJ11 is not referring to the size or the number of pins or the shape of the plug. It's referring of how the wires are going to be connected to the pins. On RJ11, you have the negative pin going on to pin 3, the positive pin going on to pin 4. On the RJ14, you have a negative wire going into pin 2 and a negative wire going into pin 3 and a positive going into pin 4 and pin 5. On the RJ25, you have 6 cables. The negatives going into 1, 2, and 3, and the positives going into 4, 5, and 6. These wire diagrams are used for phone lines. The RJ11 can carry 1 phone line, the RJ14 can carry 2 phone lines, and the RJ25 can carry 3 phone lines. Now let's take a look at the RJ45 and RJ48. The RJ45 is the most common. They are both used for Ethernet, and they're used for connecting to a local area network. So you might have one of these connected to your PC at the moment if you have it directly connected to a switch, or you might have it connected to maybe your PlayStation or your Xbox if you have it connected directly to your modem perhaps. The difference between the RJ45 and the RJ48 is that the RJ45 uses a unshielded twisted pair and the RJ48 uses a shielded twisted pair. You'll notice that they both require a category 5 or higher cable. And this is what a RJ45 and RJ48 look like. I'm sure you've seen this before. I'm sure it's connected to your computer if you have it directly connected to the internet, to the Ethernet instead of Wi-Fi. If you want to connect these guys, you put the type of diagram, the kind of standard that you want to have it connected to, the color coding, and then after that you use a crimp to squeeze it, and the pins drop down and squeeze against the wire. Now let's talk about the color coding. So you have this color coding here, which is a T568B, and you have this color coding, which is a T568A. The only difference is that the green wires swap places with the orange wires. So you'll see that 1 swaps with 3, and 2 swaps with 6. See over here, the orange wires swap with the green, 1 swaps with 3, and 2 swaps with 6. The other wires remain the same. Now, if you have a wire going through and you have the plugs and the color coding on both ends as a T568A on here and a T568A on this side, then you got yourself a straight through cable. This side could also be a B, and this side could be a B, and you still have a straight through cable. Straight through cables are used for devices that are not alike, such as a switch to a router, a switch to a PC, a hub to a PC or a server. Now, if you have a T568B on this side and a T568A on this side, if they're not alike on each side, then you have a crossover cable. And those are for devices that are alike. So if you're trying to connect a switch to a switch, then you want to have a T568B here and a T568A here, or vice versa. And you can connect a switch to a switch to a hub to a hub, a router to a router Ethernet port to a PC NIC, or a PC to a PC. Speaking of internet, another different ways that you can get internet would be Ethernet over power line or Ethernet over HDMI. And those bad boys look like this. This would be a Ethernet over HDMI. You connect your RJ45 right here and then your HDMI here, and now you have Ethernet. If you want to do over power line, this connects to your wall socket. You connect your RJ45 or 48 right here, and now you have internet, and it's all done through the power line. If you want to set up the socket where the RJ45 plugin is going to go into, you're going to need, of course, a socket itself, set up the diagram, either the A or B standard, and then you will also use a punch down tool. And I'll show you, and I'll put some links on the description below to show you how to properly use the punch down tool and the crimp. But basically, use a push down tool. You set up the cables exactly how you want them, and then you use the punch down tool and you press on these locations here, and it presses it down, and now you have them safe and secure there. Next up, we're going to go ahead and talk about optic fibers, and as you can see, there's many of them, but we're only going to go ahead and focus on 4 of them, which is the LC, SC, FC, and ST. The ST is a straight tip, and it's an optic fiber connector. It uses a bayonet style plug-in and socket, and it's pretty standard when it comes to commercial wiring. You have the FC, a fiber optic connector, and it has a threaded body, and it's designed for high vibration environments. It's used in single mode and polarizing mode. You have an SC, which stands for a standard connector or subscriber connector, and it uses a push-pull mechanism, like a latch mechanism, and it's similar to a lot of audio and video cables. It uses a unidirectional, and if you want to use it in bidirectional, then you need to have 2 cables. One cable sending direction one way and another one another way. And you also need 2 SC or standard connector connectors. You could also have the LC, which is a local connector, and that's half the size of the SC, the standard connector. And that can be easily terminated with any adhesive. So at the very end, you can add a little bit of adhesive and it won't bounce back information. And it's pretty good performance, and it's highly favored in single mode. Now let's talk about cable standards. So when looking at this, these cable standards, these cables here, both of these sections right here, are both in the physical layer of the OSI model. So you have application, presentation, session, transportation, network, data link, physical. These are both in the physical layer of the OSI model. That's good to remember. You have a 10 base T, you have a 10 base 5, you have a 100 base TX, a 1000 base TX, you have a 10 gigabyte base ASR. Basically what this is like a faucet. This is the amount of information that can be pumped through a hose. And the hose being the cables, these different category cables. So for example, say you want to send, say you have a 10 base TX of 100 megabytes per second baseband, then perhaps you might want something like a category 5, because that can send 100 megabytes per second at 100 megahertz. You wouldn't want something like a category 8 using a 10 base T, where it can only pump 10 megabytes per second when you have a hose that's too wide. It just makes no sense. Plus, these category 6, category 7, category 8, they tend to be expensive wires. You'll also notice that some of them have different lengths. So for example, the 10 base 2 has a 200 meter in between segments. That means that you can have a telephone line right here, and then 200 meters later you can have another telephone line, and then another 200 meters you can have another telephone line. It could be shorter than that, but it can't be longer than that. Otherwise you start losing quality. If you come down here, you'll see that I've highlighted this one, the 10 base TX. This is a optic fiber, but it wasn't very successful, at least not commercially. Also, you'll notice that there's a half duplex and a full duplex. Half duplex means that you can send or receive, but you can't do both at the same time. Full duplex means that you can receive and send at the same time. This specific cable, the 100 base FX, can be 400 meters in segment if it's half duplex, and it can be 2 kilometers if it's a full duplex per segment. Another thing good to notice would be that the 10 base T is called an 802.3. This is the name of the standard. The 100 base is an 802.3U, and then you have an 802.3AB and 802.3AE. So you might, if you're taking any kind of test, you might want to memorize these. Now let's go ahead and talk about plenum. Plenum is just referring to the space right here where perhaps air is circulating or not circulating. If it's not circulating, then it is a non-plenum, and you don't necessarily have to use a plenum cable, though I suggest that you do, because sometimes these vents could have a break in there. There could be corrosion. Maybe there's a faulty assembly or whatever it might be, and you could have some air leak out in there. If a rat comes along and nibbles on one of these cables and it's not plenum, then you can get some sparks. The air brings in oxygen, and that can start a fire potentially. You'll see that there's also these things called riser cables, and riser cables are needed whenever cables are being sent vertically up. You'll also see that plenum cables are sometimes used down on the floor, in between the actual floor and the elevated floor or rised floor. And then it goes up to riser cables again, and then you have your general purpose cable that's connected to your servers. In a plenum environment, you'll have air that comes in through a vent and it circulates down here, and then it gets pumped right up, but there's no other vent that directs it exactly out or directly out. Instead, the air just kind of sort of circulates. In environments like this, then you are legally required to have a plenum cable. Plenum cable is hard to ignite, and if it does happen to ignite, it does not release any kind of toxic fumes. Anyways, that's the end of this video. Hopefully you got something out of it. Hopefully this helped you out and kind of understand cables. And I'll put a bunch of different links for you to do a little more research if you're interested in. If you enjoyed or got any kind of education or enjoyment out of this, please consider subscribe or like the video. I'll try to put a video up every week.